Welcome to Lecture 3 for Bio 103. This lecture will cover the topic of water. Water is a molecule that fully supports life. If you take a look at how much of the Earth's surface that is covered in water, it comprises 70 to 75% of the entire Earth's surface. If you take a look at the water composition of the cell, 70 to 95%, depending on the cell type, is comprised of water molecules. So water is very important for life on Earth at both the cellular and organismal level. We should already know that water is considered to be what we call a polar molecule. And this polarity allows for a lot of hydrogen bonding between water molecules. This is going to be very important in allowing water to interact with other water molecules as well as other different types of molecules. There are four main central properties of water that allow for life to occur. So it's important that you know all of these properties, be able to define them, and know how they are important with water and how it interacts with its environment. The first property is cohesion. Water can also moderate temperature in summer seasons and fall. Ice floats, which is a unique property of water. Most compounds are actually more dense in the solid form, whereas water is less dense. We will see why in a few minutes. And water is also considered to be a polar solvent. I cannot emphasize enough, it is very important for the duration of this course. When you hear the word water, you should automatically be thinking water is a polar molecule. What that means is that water has electrons being shared unequally, and because it is polar, you will have a slightly negative or slightly positive region. So I would just like to take a few seconds to review the concept of hydrogen bonding. Remember that oxygen is considered to be highly electronegative, and as a result, it's going to be more likely to hold electrons towards it. When oxygen combines with hydrogen to form a water molecule, those electrons that are being shared are going to be held closer to the oxygen atom because of its high electronegativity. This results in oxygen having the slightly negative charge. Because the electrons are being slightly pulled away from the hydrogen atoms, they are going to have a resultant slightly positive charge. This leads to that polar covalent bond, with oxygen being slightly negative while hydrogen being slightly positive. When oxygen molecules and water molecules interact with other water molecules, they have the potential of forming many hydrogen bonds. So the slightly positive region of a water molecule will line itself up with the slightly negative region of an adjacent water molecule. This will create the hydrogen bond. Remember, this is a very weak interactive force, but when you have many hydrogen bonds, you can have them increase in strength. Every single water molecule that exists, say in a beaker, has the potential of making 4 different hydrogen bonds. The oxygen, remember, will have 2 lone pairs of electrons. They will have the ability to line themselves up with the slightly positive areas of adjacent water molecules, whereas the areas where hydrogen is present, which has a slightly positive charge, can line itself up with the slightly negative oxygen region of adjacent molecules, as seen in the diagram here. Water has very unique properties. Like I said before, they have cohesion and adhesion, and it's very important that you know the difference between these two terms. Cohesion refers to the instance where molecules stick together. This is a form of adhesion, but when you're dealing with cohesion, you're dealing with the water molecules sticking to other like water molecules. This allows water to form droplets and allows for surface tension. So when you have rain droplets, for instance, after a rainstorm, those water molecules will ball up together. They'll be attracted to each other due to their cohesive forces. Adhesion is when water can stick to other like substances or other polar substances. So this is how water would interact with, say, a glucose molecule, which is also polar. You would have adhesive forces in action in that interaction. Water is important in moderating temperature. This is because it has a high specific heat and a high heat of vaporization. So water can easily absorb and release heat. It is considered to be a good insulator. If you take a look at coastal regions, they tend to be much cooler during the summer months because water nearby can help moderate and cool the air as it's flowing over the land. Similarly, in the wintertime, water can have an insulating effect as well by creating a layer of ice that will help to warm the land and moderate the temperature. It has a high heat of vaporization, and this can lead to evaporative cooling. When you are working out and sweating, you have water molecules that will bead up on your skin. As those hydrogen bonds that are holding the water molecules together cohesively, as energy gets absorbed and those bonds start to break, you have the heat of vaporization, and that will help to cool the body. So that's why you have evaporative cooling. Water is also considered to be a polar solvent. Whenever you hear water, once again, you should be thinking it's a polar molecule. So it can dissolve a lot of other polar substances. And finally, the dissociation of water molecules, which means the breakdown of water molecules, can create what we call the pH effect. And this will be very important for this presentation. Here we have an illustration of how these properties can all interact to make water such an important molecule for life on Earth. If you consider the water table, we have water that exists in the soil. This water is going to then be pulled up by the roots of plants. How it is pulled up is by looking at the specific properties of water that we just looked at. So at the top of the leaves, you will have transpiration or evaporative cooling occurring. The water from the leaves is going to, the hydrogen bonds between the water molecules are going to break and cause water to exist in the gaseous state. As this is happening, this will create a pressure difference that will help to pull up water molecules from the rest of the tree. So water molecules are going to get pulled up from the root system. How do they get pulled up through the root system is due to their cohesive and adhesive properties. So along the vessels of the plant, there's going to be specific vessels that are responsible for conducting water. These are considered to be polar, so as a result, they will interact very well with water. So as evaporative cooling is occurring at the top of the plant, water is going to be drawn up and it's going to be attracted to the sides of these vessels. Remember that water is also very cohesive, so as these water molecules are being drawn up the plant, they are also going to pull adjacent water molecules with them. So all of these properties of water make it very important to support life on Earth. Another important thing to remember about water is that water is a bent molecule. That means that even though it has an oxygen with two hydrogens attached to it, it does not exist in a linear form. Remember, there are two lone pairs of electrons that are present on the oxygen, in addition to the two hydrogens that are bonded to oxygen. Electrons carry negative charge, so that means that there's going to be attractive forces between the oxygen lone electrons and hydrogen. There's going to be repulsive forces between the hydrogens and also between the lone pairs of electrons. So as a result, you have attraction and repulsion forces that create this tetrahedral-like shape. This bend is going to help to push the hydrogens a little bit closer together. An important aspect of water or property of water is the fact that it floats when it is in the solid form. Like I said previously, this is in contradiction to most other molecules. Most molecules are going to be more dense in the solid form, and as a result, they would tend to sink rather than float. So the solid form of ice is less dense because of those hydrogen bonds. So what happens is when you get the water molecules in the liquid form, remember that the water molecules are moving around, they're forming these hydrogen bonds, they're interacting with each other, interacting with other molecules, and when you have them going into the gaseous form, remember those hydrogen bonds are being broken, energy is being absorbed, and then you get the water going into the gaseous state. As the temperature cools and as these water molecules get cooler, they tend to stop moving. And when they completely stop moving, that would be equivalent to them forming a solid ice structure. So when water is forming ice, what is happening, if you can see in the diagram here, is that the water molecules are making this hexagon-like structure with their hydrogen bonds. This creates a lot of space between the water molecules, and this is the reason why ice would be considered less dense. Because of all of this space, there's a lot of opportunity for air molecules to come in, and as a result, ice floats. This is very important because this is what makes water such a good isolator, particularly when ice forms. Water is considered to be the solvent of life. So it is, remember, a polar solvent. It can dissolve a wide variety of substances. Some important definitions that you should know is what is a solution. So a solution consists of a completely homogeneous liquid mixture. It is made of both the solvent and the solute. So the solvent is what the dissolving agent is in the solution, whereas the solute is what is being dissolved. Water is once again considered to be a polar solvent. I cannot emphasize enough. This is very important for you to remember. So polar, meaning electrons are being shared, how they're being shared unequally, and because it's polar, we should have slightly negative and slightly positive regions. Aqueous solutions are known to have special properties. So when something is in an aqueous solution, like a lot of the solutions that you would normally be working with in the lab, if you have HCl with a little AQ next to it, that refers that you have hydrogen and chloride ions in an aqueous solution. So that means that these ions, hydrogen and chloride, would be surrounded by water molecules. They would be fully hydrated. Water is important because it can dissolve so many substances, and how it does it is by creating these hydration shells. So the water molecules will be able to interact with the solute, surround it to help break it apart and to help dissolve it. When you hear the term hydrophilic, keep in mind that something that is hydrophilic is considered to be water-loving and therefore will be soluble in water. Something that is hydrophobic, on the other hand, is considered to be water-fearing and would be insoluble in water. So an oil, for instance, would be something hydrophobic. It would not be soluble in water, whereas salt or sugar would be considered hydrophilic. This slide depicts an example of how water interacts with different types of molecules. If you had salt, for instance, salt is, remember, an ionic type of bond. Sodium and chloride bind together. Sodium will give up that electron and chlorine will take it in. When salt is placed in a beaker of water, it will start dissolving. And what happens is the water molecules will come in and start separating out the sodium and the chlorine ions from the original compound. And it will form hydration shells. So take a look at the orientation of these water molecules around these ions. Sodium has a plus, which means that it has given up its electron, so it has a positive charge. It is a cation. And when it is placed in a hydration shell, because you have a positive charge, water is going to surround it with the slightly negative region of oxygen facing towards the molecule. Conversely, when you have the chlorine ion with a negative charge, when water comes in to form the hydration shell, it is going to have the positive area of hydrogen oriented towards the ion. Glucose, as seen here, is another polar molecule. If it's a polar molecule, then it will have slightly positive and slightly negative regions. So if you take a look at the inset diagram here, wherever glucose has a slightly positive region, water is going to come in with the slightly negative region of oxygen facing forward. Conversely, on the slightly negative region, water is going to form the hydration shell, but the orientation of that water molecule would be so that the hydrogen is facing towards the molecule. Once you get that entire molecule surrounded with a hydration shell, it is considered to be completely dissolved. That is equivalent to an aqueous solution.